Hello and welcome to our video. My name is Hana and today my group and I from MAM21 Group 9 will be presenting about transformation of graphs. See, it is always a straight line. An example of the basic equation will be y or fx. It's the same thing, equals ax plus b. Y is the dependent variable, so the value of y is dependent on the value of x. B is the y-intercept of the graph and A is the gradient. The gradient is basically a measure of how steep a graph is, so the bigger the value of A, the steeper the graph will be. B, which is the y-intercept, is the point where the graph line, this one, touches the vertical axis or y-axis. Over here we can see it's -1, so the point is 0, -1. That's the value of B. So the equation we have here as an example of a linear function graph equation is y equals 2x minus 1. So as we've seen, -1 is the b value, the y-intercept, and 2 is the gradient, which is the measure of how steep it is. And here the x-intercept, where the graph line touches the x-axis. Next we have the translation of linear graphs. So the example number 1 is the original equation fx equals 2x minus 1. This is what the graph line looks like, and it changes to fx plus 2. So then when this happens, it means all the x in the equation will be added with the 2. So when we expand it, we get x plus 2 minus 1, fx plus 2 equals 2x plus 3. So from 2x minus 1, it becomes 2x plus 3. This is the new line of graph for fx equals 2x plus 3. So what happens? Basically, when we plus 2 to the x, the graph translates 2 units to the left. So from here, for example, 1, 2 to the left, because when x plus 2, it goes 2 units to the left. So when x minus 2, it will move 2 units to the right actually. So for example, this point here, which is 0, this point here, sorry, which is 2, 3, goes to 0, 3. See, original when y equals 3, x equals 2, after change, y equals 3, x equals 0. Originally 2, now 0 because it minus 2, as in 2 units to the left. The second translation we have is using the same equation, fx equals 2x minus 1, but this time we're doing fx plus 3. So for this one, it's different from the first one, as the plus 3 is not inside the x but outside the x. So basically you're taking the whole equation, 2x minus 1 plus 3. We're not doing it like just now where only the x is plus 3. So fx plus 3, then you'll get 2x plus 2. That's the new equation. So this is the line of fx equals 2x plus 2. What happens is that the graph translates 2 units up. Okay, for example, we have this point here, 1, 1, and then it moves up by 3. 1, 2, 3, 1, 4. See, for example, x equals 1, y equals 1, and the new graph x equals 1, y equals 4. So it just goes up by 3 units. Okay, and the third translation is a reflection. So fx equals 2x minus 1, same equation for the base, and we change it to negative fx. So the whole equation times negative sign. In the end, you'll get negative 2x plus 1. Negative 2x, negative plus 1. So the new graph line will look like this, the pink line. What happens is that the graph is reflected on the x-axis. The x-axis is the horizontal line here, which is also the line that is lying down. And as you can see, it's reflected that way. So you can see that the x-intercept remains the same, 1 over 2, and it just reflects on the x-axis. it'll flip on this dotted line here. And now we have the second reflection, which is y using the same base equation, y equals to x minus 1, but this time f negative x. So the entire x is timed to a negative. So the new equation will be negative 2x minus 1. As you can see, the negative 1 does not times the negative sign, only the x. So what happens is that the graph is reflected on the y-axis. So this is the new line of the graph, and the y-intercept remains the same. So the original y-intercept is negative 1, and it still remains the same on the new graph line.
Quadratic functions. It's also called parabola. The equation for a quadratic function is y equals to ax squared plus bx plus c. It is always a U-shape. Its only difference is that it can be opened upwards. Downwards vary in width and in steepness of the curve. In quadratic functions, a can never be 0, or it will lose its purpose. The first translation is f bracket x plus a bracket, and I'll be using fx equals to x squared minus 2x plus 1. And when I use f bracket x plus 2 bracket, it will become x squared plus 2x plus 1, which then translates 2 units to the left. From the start, y equals to x squared minus 2x plus 1, the purple line, to the black line, y equals to x squared plus 2x plus 1. On this slide, you can see that the curves are open downwards. This is because a is smaller than 0, which is negative. This will then make the lines move downwards rather than upwards. The second translation is f bracket x bracket plus a. This will translate the graph upwards by 2 units because x is added from the outside, not the inside. And this is also another example where a is smaller than 0. The first reflection is y-axis reflection, and I'll be using fx equals to x squared minus 2x plus 1. When x is negative in f bracket negative x bracket, it will be reflected on the y-axis, making the equal equation to flip to the other side by using the y-axis. The second reflection is when the minus sign is outside of the x in the bracket. This will then reflect the curve on the x-axis. As you can see, the black line is x squared minus 2x plus 1. And when fx becomes negative fx, the equation will be negative x squared plus 2x plus 1. This will then make the graph reflect on the x-axis, which is now the red line, negative x squared plus 2x plus 1.
Hello, my name is Ashton. I'll be presenting about the cubic function graph. So regarding the characteristics of the graph, it will have 2 critical turning points, which is the maximum and the minimum. And the cubic function graph will have either 1 or 3 railroads. In other words, the railroads are the solutions to the equation, because the graph will always cross the x-axis. So the graph itself will have a lot of curves, and the shape looks like an S, which is common in a lot of roller coasters, as you can see here. So the cubic function graph will come in the form of fx equals to ax to the power 3 plus bx to the power 2 plus cx plus d. So a, b, c, and d will all be constants, which means that they are all real numbers. And a can be either negative or positive, but it will never be equal to 0. So moving on, I'll be talking about the transition. So the parent graph of the cubic function is y equals to x power 3. So the graph will shift vertically when numbers are either added or subtracted after the cube part. So for instance, if you're given the equation y equals to x power 3 plus 2, the graph will translate up by 2 units because 2 is added after x power 3. Whereas if you're given the equation y equals to x power 3 minus 2, the graph will translate down by 2 units because 2 is subtracted after the x power 3. And furthermore, the graph would shift horizontally when numbers are added or subtracted to the cube part, not after the cube part. So for example, if you're given the equation y equals to x plus 4 to the power of 3, the graph would translate left by 4 units. And if you're given the equation y equals to x minus 4 to the power of 3, the graph would translate right by 4 units. So any numbers that is positive in the bracket, the graph will always shift by left. And any numbers that is subtracted to x in the bracket, the graph will always shift by right. So finally, I'll be talking about the reflection of the cubic function. So if a negative symbol is added before the f, so given the equation y equals to minus f times x, it will be a reflection on the x-axis. Whereas if a negative symbol is added inside the bracket after x, before x, it will be a reflection on the y-axis. So as you can see here from the two graphs, the both functions will result in the exact same graph, so that they will overlap each other. And that's all of my part. Thank you for listening.
Hello, my name is Somanesh and I'll be presenting the translations and the reflections of a square root graph. For today's graph, I'll be using the function square root x. Just by looking at the graph, you may notice two things. Firstly, the graph is always curved, and the second one is that the graph looks like half of a parabola, or also known as the cubic graph. For the translation of a square root graph along the y-axis, it can be achieved by adding or subtracting a value on the outside of the square root symbol, as per the example given, which is function equals to open bracket square root x close bracket plus a. If a is a positive value, the graph will be translated upwards, while if a is a negative value, the graph will be translated downwards. If you observe the example shown, when the function is root x plus 1, which is the blue graph, the graph translates up by 1 unit, and when the fx is root x minus 1, which is the red one, the graph translates down by 1 unit. For the translation of a square root graph along the x-axis, it can be achieved by adding or subtracting a value on the inside of the square root symbol, as per the example given, which is function equals to square root x plus b. If b is a positive value, the graph will be translated to the left, while if b is a negative value, the graph will be translated to the right. If we observe the example shown, when the function is root x plus 2, the graph translates to the left by 2 units, which is the blue graph. And when the function is root x minus 2, the graph translates to the right by 2 units, which is the red graph. Lastly, the reflection of a square root graph about the x-axis and the y-axis. To obtain a reflected graph, a negative symbol must be added to the function. If the function is negative square root x, the graph will be reflected about the x-axis, which is the red graph, while if the function is square root negative x, the graph will be reflected about the y-axis, which is the blue graph.